Hey guys, got another teardown video. Yes, I can't help but take screwdrivers to things, but I enjoy it. What I've got here sparked my interest. I found it on eBay. I had to pay a reasonable amount for it. It was a bit more than I normally pay for these things, but it sparked my interest because it is a Thermocouple temperature data logger. And usually it has no screen, it just prints out to a piece of paper. But it's got 5 channels and can log up to once per second, I think. But this sparked my interest because I built this a number of years ago, which captures 3 channels of K-type temperature. Displays it on the screen, you can data log with it and save to an SD card and all that sort of stuff. So, but this will be coming up in a future video because it might be of interest to some people. I don't really use it that much now, but yeah, I'll take this apart and show you why I did this and how I ended up with this design. So anyway, back to this. So we're going to take this apart. It does work, so I'll show you it working first, which is always good to have things that are working. I don't know, maybe it come in useful sometime. So anyway, let's take a look at it. So yeah, taking a closer look at this. Really nice case. I don't know how much this cost originally, but the amount of effort they've gone into making this case. You've got your rolls of paper in a nice, perfectly formed little circle there. It's really nice. So this probably cost way more than what it should have done. So you've got an old transformer style plug pack. This came with a spare printer ribbon. On a K-type probe. So you've got a spare roll of paper and the unit itself. So the legend on the back, you've got refer to operator's instructions. You've got connections, you've got the thermocouple inputs. It runs off batteries. In fact, I've not actually managed to get this to work off the power supply that it came with. So I suspect that is just a charger. So you can either switch it between running off disposable batteries or NiCads. Okay, so I've got some batteries in there now. If we turn it on. Okay, so I have to confess I've read the user manual and I've got a pretty good idea on how to actually use this now. So I'll just quickly show you a few bits of it. If I grab one of my K-type probes. If I select channel and do single, that should tell me the current temperature. It says there 1604 and 23.8 because it's a nice day today. The keypad is sort of a horrible feeling membrane thing. Pretty cheaply done. So on the back here we've got 2 screws up there and none in there. So okay, so we've got 2 boards in here. This one's clearly double-sided. We've got flat flex running in here. That could well be for the keyboard. Fuse. And the connections to the external ports. Okay, so we got a little 100 milliamp hour, probably nickel cadmium rechargeable battery. We got the clock crystal there. That's the switch to change between disposable or rechargeable batteries. Got a couple of trim pots. This was the connector that went to the other board, and we've got a nice big 40 pin package there. That's obviously a microcontroller, so it's probably a PIC or something, and then we'll have a look in a moment. Some relays, 1, 2, 3, 4, 5, 6, and then we have we've got the wires coming over from the back of the K-type connectors running to here, the temperature sensor, because obviously the way K-type thermocouples work is it's two dissimilar metals, so you have a hot junction and a cold junction. The hot junction is obviously what you want to measure, but then you need to know the cold junction temperature as well to be able to work out what the actual temperature is. So you always need to measure the temperature somewhere on the system to be able to do the cold junction compensation. So we've got a date of 7th of the 12th 1993, so that certainly dates this pretty well. And there you go, I was thinking it was a PIC, and it's not, it's a Hitachi. So we've got a HD 63705 microcontroller. I'll look up the details of that in a moment. So just looking at this part here, I was looking for a real-time clock chip, and I can't seem to find one anywhere. Obviously we've got the crystal here. The only thing that I'm thinking is this here is a 14-stage binary counter, so I wonder whether they're actually just dividing or counting the crystal here, and then the microcontroller works out the date and time and all that business. I'm surprised they've done it like that, to be honest, considering you can just get off the shelf devices which can handle all of that, date, time, calendars, and etc. But there we go. So here we've got a multiplexer, and this is an ADC. So it appears as though they're not, either this doesn't have any ADCs in it, or they're just not using them. Now this is actually it's called a precision analog front end, but it is an ADC as well, up to 17 bits. So quite an impressive little device. Okay, just having a quick look at this secondary board. the printer, and I would suspect this is all the driver circuit for the printer, possibly off the shelf, although it does have... Oh no, it isn't. That's Kane, that's their logo. So this is obviously a print board that they've designed, possibly used in other applications. Large ASIC there, dated 1982. So well, this is going back a bit. Quite clearly, this is obviously an older design, used in conjunction with this thing from 1993. Some 11 years after this, which is surprising. Okay, last to look at is the case. It's all pretty basic stuff. That's the flat flex that runs through to the membrane keypad on the other side. We've got the other side of the battery box, and of course the K-type. There's me been fiddling around with that, and all I had to do was take that out. Oh well. So that's the K-type connectors there. There we go. I think that's about all there is to see on this. I didn't really expect a huge amount of interesting stuff in this, because it is quite a simple device really. Microcontroller, analog inputs, AD converter, printout, that's about it. So, well, I hope you found this interesting. I did a little bit moreover because the K-type, the multiple K-type inputs, I was interested in how they did that. Thanks very much for watching. If you like this, hit the like button. If you've got any comments or questions, whack those into the comment section, and I'll see you on the next video.